Hi, my name's Agam Singh and this is my video for Lab 1, Charge Tapes. The purpose of Lab 1 was to further our understanding of charges in dipoles. A dipole can be described as two-point charges of opposite signs. You can create an induced dipole moment by rubbing, pulling, or touching objects against one another, so neutral objects can acquire more or less of a negative charge. By doing so, we can determine an approximation of excess charge left on charged pieces of tape. We can also determine the charge by interacting them with other items of charge. In this lab, we're going to be using tape to demonstrate how neutral objects can become charged and how we can figure out their charge and the number of electrons they've acquired or lost. This is done by applying a base tape on a table and then applying another tape on top. The top tape is then quickly ripped off from the bottom tape, acquiring some electrons, therefore having some sort of charge. Then a series of experiments are done to these tapes to figure out the following results. When the U-tape and the hand are brought together, they attract. When the two U-tapes are brought together, they repel. The U-tape and the book also attract, and the U-tape and the negatively charged pen attract. This shows that the top U-tape is positively charged because it is attracted to the negatively charged pen, which I rubbed against in my hair. In the next experiment, we suspended two positively U-tapes on top of one another. In the diagram below, you can tell that they created some distance as they repelled against one another. This distance now can be used to determine the charge and the number of excess or lost electrons. The assumptions that we used during this experiment were the following. Both tapes are neutral before we charge them. A tape can be described as a point charge. Both tapes have equal net charges, and we can ignore any air resistance during the experiment. Now for the data portion of this lab. The length of one piece of tape is 0.202 meters. Clear tape is around 1 gram per meter. The mass of the tape was 1.5 times 10 to the negative 4th kilograms. The distance between the two tapes when they began to float above one another was 0.023 meters. The magnitude of the gravitational force can be calculated by the mass times g, which is 9.81. So that was multiplied by 1.5 times 10 to the negative 4th, which gave us an answer of 0.00147 newtons. The magnitude of the electric force can be calculated by K, which is 9 times 10 to the 9th, times Q, which is charge, over distance squared, which is the same as the gravitational force, which is 0.00147 newtons. For the calculation part of this lab, we continuously use Coulomb's law, which states force equals K, which is 9 times 10 to the 9th, times charge over the distance squared. We assume that both pieces of tape have the same charge and both are treated as point charges. From Coulomb's law, we can derive an equation for charge, which is Q equals the square root of force of gravity times K times the distance squared. That gives us a charge of 9.3 times 10 to the negative 9th coulombs. Using that the charge of one electron is 1.6 times 10 to the 19th coulombs, we can determine the number of excess electrons, using that the resultant charge over the charge of one electron, which gives us 5.81 times 10 to the 10th. As stated below, the number of excess electrons can be calculated by the resultant charge over the charge of one electron. That gives us, again, the number of 5.8 times 10 to the 10th. The number of atoms on the tape can be calculated by the length of the tape divided by the diameter of the atom, which is 0.202 over 1 times 10 to the negative 10, which gives us 2.06 times 10 to the 9th atoms. This can be used to calculate the fraction of surface atoms with excess or lost charge. This gives us 1 times 10 to the negative 6th. We assume that atoms gain or lose at most 1 electron charge. Thus, only 1 in a million atoms on the surface of the tape has acquired an excess electron or lost an electron, a very small fraction. For the lab, we had to create a code that creates the tapes as 2-point charges, calculates the electric field amount of excess electrons and the charge of the tape, then creates arrows for the gravitational force and the electric field force. And then on the bottom, we had to call lab 0, the function that we created in the previous lab. As you can barely see, you see two green and blue spheres that represent the two U-tapes separated by some distance d. The red arrow shows the electric force and the orange arrow shows the gravitational force. The code then prints out the charge of the U-tape, the electric field, and the amount of excess electrons created by the tape. To conclude, if the electrons had a positive charge and the protons had a negative charge, then the interactions would have been reversed, but the two U-tapes would have still repelled each other because opposite charges repel. And it is really important to handle the charged tapes as little as possible because our hands are neutral, so it attracts the charged tapes. So if it comes in contact, then the charge/electrons could transfer over, thus changing the entire charge of the tape, which would have given us inaccurate results of the charge and the number of excess electrons. Thank you for watching.